Hi, welcome back to this channel. We continue with the topic of electrolysis. We already done for the molten salt, water, concentrated and dilute aqueous solution. Therefore, in this video, we are going to focus on aqueous sodium sulfate solution and also another few of examples. So let's start. So let's continue with electrolysis of sodium sulfate solution using the platinum electrode. So based on this title, we're going to know that the type of electrode that we use is inert electrode, and then the species present in the solution are water, Na+, and also SO4 2 negative. So now we will know that water and cation ion, which is the sodium ion, will attracted to cathode and they are going to undergo, we need to select one of them to undergo reduction. So how we choose it? We will look at the SRP value, which is more positive. So I think we repeat this one for a few times. You already have the idea that between these two, negative 0.83 is more positive, so means that water will be selectively discharged due to water has more positive SRP value. Okay, now then we're going to know that sulfate ion, which is the anion, water will be attracted to anode and oxidation supposedly happen, which we will choose the one with the more negative SRP value. So here we have two half equation, which one will be involve the sulfate ion, and then the other one is involve the water. So based on these two SRP value, basically positive 0.2 is more negative. However, in this case, water will be selectively discharged. Water will be selectively discharged. So then now we need to know why water will be selectively discharged. Because the oxidation number of sulfur in the sulfate ion. So let's calculate the oxidation number in the sulfate ion. We have no idea, let's say the oxidation number of sulfur, so we place X plus 4 oxygen is negative 2 equal to negative 2. So the oxidation number for sulfur in this case will be equal to positive 6. As we know that oxidation number for sulfur, as we know that sulfur is in group 16. So basically its oxidation number, the highest step for its oxidation number will be positive 6. Then this is why sulfate ion cannot be oxidized. Sulfate ion cannot be oxidized because we understand that if sulfate ion oxidize means that it will increase the oxidation number from positive 6 to higher oxidation number. But just now we already mentioned that positive 6 is the highest. So that is why this cannot be happen. So here if we make it further, we say that because the oxidation number of sulfur in sulfate ion is in its highest state, even though it has more negative SPR value, but it will not be selectively discharged. Okay, so with this, then we can write the half equation at the anode, which we reverse this equation because this equation now is in the reduction form. So we just reverse the equation, make it become oxidation equation. Then the half cell equation at the cathode is already stated in the previous slide, which is 2 mole of water, gain 2 mole of electron from 1 mole of hydrogen gas and 2 mole of OH negative. Then again, like previously we already discussed, this is 2 mole of electron and this is 4 mole of electron. So this half equation need to multiply by 2, so this one will become 4H2O, 4 more electron, 2 more hydrogen gas, and 4 more H2O. Then now we know that 4 more electrons can be cancelled out. Then we just like combine these two half equations. Then we'll be end up with only have 2 more H2O, produce 2 more hydrogen gas and 1 more oxygen gas. So just remind that here 4H plus and 4OH negative going to form 4H2O. So the 4H2O at the left hand side and right hand side here can be cancelled out. So that's why we only left 2 more H2O, 2 more hydrogen gas and 1 more oxygen gas. Okay, basically we already finished the topic of predict the product when the electrolysis is happened. So now we continue with the tutorial question number 2. So write the half equation and determine the product form and the anode and cathode in the electrolysis of dilute and HCl solution. So again, as we know that when we have dilute and HCl solution, means that we have Na plus, Cl negative, and H2O. So when we have at the anode there, Cl negative and water will be attracted to anode. So between these two, water will be selectively discharged due to the concentration of water is higher than chlorine gas. Chloride ion, so that's why water is selectively discharged and will be, because at the anode, so we can see the over, so oxygen gas is produced. While at the cathode, Na plus and water will be attracted to cathode. So to cathode is Na plus and H2O. So same case as well, H2O will be selectively discharged due to the SRP value. Okay, so for the cathode is due to the SRP value, and the anode is due to the concentration factor. So again, if at the cathode we can see the H first, so the product is hydrogen gas. This is how we try to minimize the mistake. Okay, then now we proceed to question B, concentrated NaCl solution. So same case, if we have concentrated NaCl solution, we also have Na plus, Cl negative, and H2O. So similar case, Cl negative and H2O will be attracted to the anode. And between these two, Cl negative will be selectively discharged because this time Cl negative has higher concentration. While at the cathode, as usual, Na plus and H2O will be attracted to cathode, and water will be selectively discharged to form hydrogen gas. This one is due to the SRP value. Next one is sodium sulfate solution. So if you have sodium sulfate solution, we're going to Na plus, SO4 2 negative, and also H2O. So like normally, we already know that anion and water will attracted to anode. But then in this case, the water will be selectively discharged and to form oxygen gas. Okay, this one is due to all the SRP value, but we are not looking at the SRP value at this time because sulfur is in its oxidation number of sulfur is in its highest state, okay, which is positive 6. Okay, then next one we look at the cathode. So same case as well, for the cathode is Na plus and also H2O. Between Na plus and H2O, H2O will be selectively discharged and form hydrogen gas. This one is due to the SRP value. So last question is the molten magnesium bromide. So if we can see the word molten magnesium bromide, means that there is no water is added. If no water is added, so means that we only have Mg2 plus and also Br negative. So there is no choice because we don't need to select which one will be selectively discharged. So bromide is the N ion will attracted to the anode, then will produce bromine liquid. While for the cathode, cation will attracted to there and then undergo reduction to form magnesium. So because of the word molten, basically is from the root word is melt. So what is melt? Solid is melt. So once solid is melt, it will turn to liquid. So that's why the physical state of the half equation for molten compound always will be in liquid state. Okay, before we end this tutorial question, have something that need to remind you. Okay, so just now we already have the idea sulfate ion cannot be oxidized because of the higher state of the oxidation number. Besides from the sulfate ion cannot be oxidized, please remark also, carbonate ion also will not oxidize, nitrate ion also will not oxidize, and phosphate ion also will not oxidize. So, will not oxidize due to its highest oxidation number. So the its here is referred to those elements which is have underline. Okay, so the highest oxidation number for sulfur is positive 6, carbon is positive 4, nitrogen is positive 5, and the phosphorus also positive 5. Proceed to objective question in the tutorial book, question number 5. An aqueous solution of copper 2 chloride is electrolyzed and the product form are copper at the cathode and chlorine at the anode. Okay, so from here, we try to analyze the question first. Since we see the word solution, then we know that Cu2 plus, Cl negative, and water are present. So Cu2 plus and water will be attracted to cathode, while Cl negative and water will be attracted to anode. Okay, then they let us know that copper is formed at the cathode. So in other words to say, in between copper 2 plus and water, copper 2 plus is selectively discharged. While chlorine at the anode, so means that chloride is selectively discharged. Okay, so copper 2 plus selectively discharged at the cathode, so means that cathode undergo reduction. And then we can say that copper is reduced is wrong because its Cu2 plus is reduced. Okay, chlorine is reduced. Similar case here, we have no chlorine as the reactant, but the chloride ion as the reactant. And then chloride ion is selected at the anode, and anode oxidation happens. So statement B also wrong. So C, water is more easily oxidized, also wrong, right? Because of, we already know that chlorine is formed at the anode. So same case as well to the donkey, copper is produced, so means that Cu2 plus is more easily to be reduced. So option D also wrong. So the correct answer for this one, for this question, basically there is no correct answer, but I think if we change this a bit, Cu2 plus is reduced. Okay, now let's continue with a few examples of which ion will be selectively discharged at the cathode. So for example, if now we focus at the cathode now, so and we know that cation ion will attracted to cathode. So in the NaCl solution, substance that will attracted to cathode is Na plus and water. So between these two, as we already discussed a few times, the SRP value for the Na plus is negative 2.71 volt, while for the water is negative 0.83. So between these two, water will be selectively discharged, and the product formed when water selectively discharged at cathode is hydrogen gas. Because of we always remember using the terms at the cathode, we can see the H first, so hydrogen gas. So the factors that we are going to predict is the SRP value. So another condition at where if we have copper 2 sulfate solution means that Cu2 plus and water will be attracted to the cathode. So as we already know, the SRP value for water is negative 0.83, while for the copper is 0.34. So therefore 0.34 is more positive and copper 2 plus will be selectively discharged, and in this case they will produce copper which is in the solid form, and then this one is due to the SRP value. Okay, since here to remember that hydrogen gas, physical state is gas, water, physical state is liquid, Cu2 plus in this case because it is in aqueous solution, so the physical state is aqueous. Okay, now we continue with the part of the anode. So anion will attract to anode. So before we want to continue at the anode side, normally we have to check is the electrode inert or no. Okay, so from here we have platinum, zinc, platinum and platinum. So among here we already know that platinum is the inert electrode while zinc is active electrode. Okay, so we do this one first based on this diagram. So if the zinc is the active electrode, so here we will going to say no. So if no, the electrode will be chloride. So means that even though we know that nitrate ion and water will attracted to the anode, but none of them will be selectively discharged because the inner electrode will corrode. So once the inner electrode corrodes, so the zinc is oxidized. So when zinc is oxidized, the product will become Zn2 plus aqueous. This is the product. And then what is the factor? The factor that we consider in this type is type of electrode. Okay, then now we proceed to another question. Platinum in sodium sulfate solution. So as we know, if in the sodium sulfate solution, we will look at sulfate ion and water will attract to the anode. So since here they didn't mention about the term concentrated, so we will look at here. Is inert electrode, so yes, and then we try to check any OH negative ion, Cl negative, Br negative and I negative, so the answer is no. So means that water will oxidize. So one of water is oxidized. At the anode we can see the O first, so the product is oxygen gas. So in this case we consider the factor that we consider is SRP value. So next one is the platinum in NaCl aqueous solution. NaCl aqueous solution means that we have Cl negative and also water will attract to the anode. So here when you can see when it is Cl negative, so they will say that will be more concentrated anion is oxidized. So that's why here Cl negative is selectively discharged. So once Cl negative selectively discharged, it will produce chlorine gas, and the factor that we consider for this electrolysis is concentration. So in other words to say, if you didn't see the word dilute, so like this one we didn't see the word dilute, we didn't see the word concentrated, we only can see the word aqueous, so we also consider them as concentrated. Last one, which is the platinum in dilute NaCl solution. So as in the third example here, both Cl negative and water will be attracted to the anode, but this time water is selectively discharged because concentration of the Cl negative is lower. So once water is selectively discharged, again oxygen gas is produced, and this time the factor that we consider is also the concentration. So with this, we are going to end the qualitative part for the electrolytic cell, at where we need to know what are the ions attracted to anode and cathode, and then how we select which ion will be discharged based on the three factors, either its type of electrode, the concentration, and also the SRP value. So in coming video, we are going to do after we already know that the product or the ion that selectively discharged, we're going to involve calculation part. So see you in next video. Bye bye.